Jai Hind everyone. I am Dr. Sneha Mishra, Assistant Professor, Department of Computer Science and Engineering, AKGC Ghaziabad. So today I am going to discuss in machine learning. We are going to discuss on the next topic, that is regression. Yes, regression. So basically, regression is the supervised learning technique that is used to model the relationships between the dependent variables and one or more independent variables also. So let's take an example. If I take an example, here we have if we take y and x, so x is as independent variables and y is the dependent variable. So if I say that if I have to predict the price of the house, right? House price. So in that case, in this case, there may be some dependent variables and some independent variables. Independent variable may be like, I can say the area of the house. Suppose it is 500 square meter, or it is 1000, or it is 900, and so on, 1500. Right? So these are the areas. So these can be considered as x1 or x2 or x3. These are the independent variables. And the price of the house is dependent on these area, like area of the house, suppose floor of the house, right? It is first floor or second floor or third floor, the facing, the PLC, right? So it is dependent on all these things. So these are the independent variables. Area is independent, floor selection is independent, PLC is independent, but the price of the house is dependent on these particular parameters. So if the price is dependent on these particular parameters, now what is the task? The task is we have to predict the price. When we are talking about predict the price, then we are saying that we have to apply regression. And which type of regression we have to apply? In this, we have linear regression, logistic regression. There are two types of regressions, linear regression and logistic regression, in which linear regression is about the prediction of anything. Suppose if I say that suppose I am saying that the certain age limit of the people is identifying whether that person is having the insurance policy or not. In that particular case, what we can say is we can identify or we can predict that whether the person, like I am saying that a person has particular age, whether he or she is having insurance or not, right? Yes, no, this may be the format, but age is like 30 is the age, 35 is the age, 40 is the age. So depending on the ages, so in that case this will be considered as independent. This will be independent. But this, since it is dependent on this, so this will be your dependent variable. I hope by this we have understood what is dependent variable and what is independent variable. So in such case, y we are saying as dependent variable, that response variable on the predicted variable, and x is referred to as independent variable. The explanatory variable also it is called, that is the predictor variable. So based on these independent variables, dependent variables are dependent, and we are predicting this Suppose we have collected the data that 90 people data, or 200 people data, or 300 people data, and that particular data is saying about that the insurance of this is age group is certainly this, certainly that, certainly that. So we are just predicting the prices of these particular values based on this independent age. So now if I say regression, it is the supervised learning technique that is used to model the relationships between the dependent variable and one or more independent variables, right? The goal of regression is to predict a continuous output based on the input variables by finding the mathematical functions, and those functions are based on y and x. If I say like applications, if I say, so predicting the house prices, I told you already, estimating the stock market trends, forecasting the weather conditions. So these are the techniques that seek the minimizing error and mean squared error to predict the actual values and optimize the model for better accuracy. So these are the applications. Let's take an example. Here we are saying that an operations supervisor measured how long it can take one of her drivers to put 1, 2, 3 and 4 cases of soft drinks into a soft drink machine. In this case, the levels of the explanatory variables x are 1, 2, yeah. So, and there is an operational supervisor and he is measuring that how long it takes one of the drivers to put the 1, 2, 3 and 4 cases of soft drinks into the soft drink machine. In the case of the levels of the explanatory variables, x are y 1, 2, 3 and 4, and she controls them. She might repeat the measurements of the couple of times at each level of x. A scatter plot of the resulting data might look like this. You can see the data is looking like this, but if I see there is some certain straight line. So this line is telling about that, yes, like the operation supervisor, the cases like 1, 2, 3, 4 cases, in such type of cases, what is the loading time or what are the number of cases? So the loading time and the number of cases are proportionally dependent on each other. So you can see the straight line is there. This is representing your linear regression, because you can see the line is straight line. If 1 is the case, then the loading time is 10. If 2 is the case, the loading time is approximately 15. If 3 is the case, then the loading time is 20, and so on. The line is still here, and it is the straight line if I see, right? So in that case, you can see, yeah, see, this is the straight line, right? So we can say that this is the linear regression, right? So now, what is the question? What is the association between y and x? How can changes of y be explained by the changes of x? What are the functional relationships between y and x? These are the questions that arise. So, as we have studied that y is the function of, see, here is the line, the diagram which we studied earlier. This is the line drawn, and this is simple, the equation of line. If you see, this is the equation of line. Right, this is the equation of line, and this is telling about that y is equals to bx. And if we talk about the slope also, then bx plus c, here is the slope, right? So b1 is the slope here b1 is this b1 is the slope. So this is the proportional relationship, right? This is the proportional relationship. So you can say that what is the association between y and x? Here you can see the association between y and x. As the value of x is increasing, value of y is also increasing. As the value of x is increasing, value of y is also increasing. So there is a proportionality relationship in this. So same as we have the equation of line, same is the equation, and this is the association between the y and x. How can changes of y be explained by changes of y? Yes, you can identify how the changes. If the value of x is changed, then value of y will also be changed. So these are the changes we explain. What are the functional relationship? Here it is the functional relationship, right? So all the three questions are being answered here only. As we move to the next slide, here is the example. You can see how we calculate. This is the slope, right? So this is the equation of line. Y is equals to b0 plus b1x, where b0 is the intercept. This is the intercept. This is the value of slope. This is the intercept. This is the slope. This is the value of x, which we are saying as independent variable. And this is the dependent variable which we have to calculate. Right? So this is how it is working. What is the intercept? The distance between these is the intercept, right? So we all are aware of about the equation of line. So yes. So this is the linear relationship, right? And this is how we identify the linear relationship, and this is how we calculate the linear relationship, right? This is the example of cholesterol versus ages. So as per the age increases, the cholesterol level may increase. The chances are higher that the cholesterol level may increase. So in that particular case, yes, one independent variable, you can easily calculate, right? Now, if we talk about, those were the linear equations where the line was exactly same. So the variables x and y were proportionally increasing. If the value of x is higher, the value of y was also higher. If the value of x is decreasing, the value of y is also decreasing. So in that particular case, the line is the straight line. So the equation of straight line was there. But if such is not the case, then how? Then all these things will remain the same. B0, B1 is the slope on different, we can have different linear coefficients. So on those different linear coefficients, B will be the linear coefficient and B2 will be the quadratic coefficient, right? So this will change, okay? So there may be polynomial relationships may be explained like this, okay? Okay, I have chosen the highlighter, I guess. Right. So these are the, this is how we represent the polynomial relationship. So if the y is saying that whether the crop will yield or not, and x is the pH level, so it may vary. Crop will yield or not. It is not necessary that if the pH level is low, the crop will yield or not, and if the pH level is high, the crop will yield or not. It is not permanent. It may vary at different times and different for different crops. So you can see the graph is not as a linear graph. So if the graph is not like a linear graph, then the equations will not be as a linear graph, right? So the non-linear relationships are being shown like this, right? And we calculate with the help of these equations. So now we come on logistic regression. See, we were discussing linear regression, and in that linear regression, we were saying that we are predicting the prices based on the independent variables. There are certain independent variables, and the dependent variable is dependent on those independent variables. So we were calculating those independent variables, calculating those dependent variables using the help of either polynomial regression or nonlinear regression or linear regression. We were just calculating all that, right? In machine learning, we are also applying these things to predict some values. It may be used in weather forecasting, very largely used, and there is not one independent or two independent variables. There are a number of independent variables, right? But in logistic regressions, we are classifying actually. So it is commonly used algorithm in logistic regression. It assumes that the dependent variable is binary, which is often the case in medical and other studies, like whether the person is having disease or not, whether the person will survive or not, whether this condition is accepted or not, whether the insurance policy will be there or not. So such are the conditions for logistic regression. So in logistic regression, you can understand that quadratic and logistic regressions does a particular non-linear transform on the data, after which it just does the linear regression on the transformed data. So after the logistic regression, we do linear regression on that transformed data, right? So logistic regression for the data uses the sigmoidal logistic curve rather than the line or output, an approximation of the probability of the output given to the given as the input. So you can see like the graph is like this. So we use sigmoidal functions for logistic regression, right? So suppose age is shown as x-axis, the input variable, and data is fictional. So we are checking the heart failure. So heart failure will be either yes or no. So output will be in the form of 1 or 0, right? So if we use the values of regression line as a probability approximation, so it extrapolates outside 0 and 1 and not as good empirically. So sigmoidal curve to the right gives the empirically good probability approximation and is bounded between 0 and 1. So here you can easily, if we talk about the linear regression, if we take this example of heart failure with the help of linear regression, then we have to collect the data in the form of like age. We have n number of ages, 30, 31, 32, 33, 34 and so on, and 60, 70, 80, 90. And the chances are, yes, the heart failure happened, but the proximity of that was higher or lower, then this particular kind of line will not give the actual predicted value, or it will not give the good results. But if we use a sigmoidal function, then in that case, the sigmoidal curve, you can see it is giving the right empirical values and it is giving the good approximation. So that is why we use logistic regression in that case. Okay. So logistic regression approach, what is the approach? It follows the learning approach and generalization approach. In learning, it transforms the initial probabilities into log odds and do the standard linear regression using the logit values, and this effectively fits a logistic curve to the data. And while still just doing a linear regression with the transformed input, it can be a quadratic machine. And the second approach, that is generalization approach, in which it finds the value of new input on the logit line and transform that logic value back to the probability. So such is the task done by logistic regression. These are the logistic regression approaches. We can see by an example that non-linear preprocess to logit, how it works. Logits are nothing, it has the log odds. So we are taking that medical dosage. Suppose these are the medical dosage, and whether the person is cured or not, total number of patients on which we have worked on, and the probability of cured and total number of patients, right? So as per the graph, you can see not cured, cured. This is the table and this is the result in the form of the graph, you can see. So probability of cured patients, this is in this graph, in this particular graph we can see what is the probability of the cured patients. This is all data and this is the logit data, right? So you can see that, one second. Yeah, so in logistic regression, could use linear regression with the probability points, but it will not extrapolate well. And logistic version is better, but how do we get it? So similar to the quadratic, we do a non-linear pre-process of the input, and then do linear regression on the transformed values, and then do the linear regression on the log odds, right? So this is the graph. It was already in the previous slide also. So the previous one was non-linear pre-process and logit, and this is also another example. And this is how, see the equations, how they work. They are using sigmoidal function, right? So this is the function e to the power minus x divided by 1 plus e to the power minus x. This is you can say it is y. This is the sigmoidal function, right? And just we are putting the things in this and we are calculating this, right? So this is how the regression of log odds are working. So now we come to the end that linear regression and logistic regression both are the nice tools, and they are working very good in many simple situations, but both force us to fit the data with one shape, like either line or sigmoidal, which will often be underfit. So they are giving intelligible results, and when the problem includes more arbitrary non-linearity, then we need more powerful models, which we will introduce. So yet non-linear data transformation can help these cases while still using the linear model for learning. So these models are commonly used in data mining applications, and also as the first attempt at understanding data trends and indicators, etc. So this was about the today's lecture about regression. We have studied linear and logistic both regressions. In linear regression, we are just having the line equation, and in logistic regression, and in linear regression, we were predicting the prices, and in case of logistic regressions, we were also doing the classification tasks. Thank you.